Welcome back. So let's do one more of those trig derivative problems. So let's say we had y equals the secant of x over x, and we were told to find dy over dx. So in a problem like this, if you remember, the quotient rule is what we use because we have something over something else. And so the quotient rule states that if you were looking for a over b prime, that equals b times a prime minus a times b prime all over b squared. So these problems are exactly the same. Again, I know I've said this before, but these are exactly the same as the ones we've been doing before, but now we just have some trig functions in them, and so we need to find the derivatives of those, or we just know the derivatives of those. So like I did before, I'm going to write down a equals the secant of x, because that's in the numerator. And so a prime equals the derivative of the secant of x is secant x tan x, or tangent x. And then we have b, which equals x, and b prime is just 1, because I use a power rule on this. And the power rule says, once again, I'm going to write it down just so you remember it. The power rule will come back to you over and over and over again, so it's a good idea to know this. X to the n equals nx to the n minus 1, and so x is just x to the first, and so that is equals 1 times x to the 1 minus 1, which is 0, and anything to the 0 is 1. So b prime ends up being 1. I'm going to write down what b squared is. B squared is just, well, that's just x squared. So now that I have all these written down, now I'm going to go ahead and plug it into this. So the quotient rule says b times a prime, so b is x, so it's x times a prime is the secant of x, tangent of x, minus a, which is the secant of x, times b prime, which is 1. So I can just ignore that because it's just multiplied by 1. It's the same thing. And this is all over b squared, which is x squared. And I think that's about it. I don't see a way to simplify this, so this is it. This is your answer. And you probably get problems that are a little more involved than this, but I did problems like these so that you get the idea of what you're doing. This is the most complex it gets. These problems don't get any more complex than this. They may be longer because you have more terms and more things to differentiate, but these problems don't get any harder than this. So these are all I'm going to do as far as trig derivatives. If you want me to do another problem, please send me an email and I will add it to this playlist. But these don't get any more complex than this. Some of them just get longer, where you have to just derive more things. So, yeah, if you have any questions or if you want me to do another problem like this, email me. And yeah, keep watching.